Hello, all you cool cats and kittens. It's Miss Gronefeld here. Thought I'd throw in a little Tiger King reference there, trying to be funny. Didn't work. All right, so today we are moving on to multiplying and dividing rational expressions. You guys have so far just simplified them. So let's start with a quick little blurb here. The procedures used to multiply and divide rational expressions are the same as those used to multiply and divide fractions. So you multiply and divide rational expressions just like you would with fractions. So for example, if a, b, c, and d are polynomials with b not equal to 0 and c not equal to 0, then this happens. So just like when you would multiply fractions, you multiply straight across. So that's what this first example right here says. If I have a over b times c over d, I would just do a times c and then b times d. If I'm dividing, you remember this as keep, change, flip, just like you would with regular fractions. You keep your first, change the multiplication or change the division to multiplication, and then flip the last fraction, and then again, you multiply straight across. So if I had a over b divided by c over d, I turn that into a over b times d over c, and then I just multiply my a and d, multiply my b and c, and then simplify from there. So let's move into the procedures for doing it. The first thing is to always simplify first. So if you can simplify, you should simplify. And then we carry out the multiplication or division. So just like in those examples above, if it's multiplication, multiply straight across. Division, keep, change, flip, and then multiply. And then lastly, you're going to simplify one more time to get your final answer. So starting off with this first example here, just looking at it, I can't simplify anything before I do my multiplication. So I'm just going to start with my multiplication first. So we're going to start by multiplying straight across. So I'm going to do x squared times 2x squared. And on the bottom, I'm going to have 4y times y squared. So once I do this, then I can continue simplifying. So x squared times 2x squared gives me 2x to the fourth over 4y times y squared is 4y cubed. Now my last step here is to see if I can simplify anything else before I get my final answer. So the only thing that I can really simplify is these numbers. So 2 goes into both 2 and 4. So if I take out a 2, I divide out a 2, I'll be left with just x to the fourth on top and 2y cubed on the bottom. And that would be my final answer. So we're just simplifying, simplify, simplify. All right, so if I have a problem such as this one, again, I can't simplify anything from here or here before I do my division. So this is where I do my keep, change, flip, KCF, keep, change, flip. So I'm going to keep my first fraction the same. Change the division to multiplication. And then flip my last fraction. Next, I'm going to just multiply straight across. So I'll have x cubed y squared over x to the fifth y. From here, I'm going to simplify one more time. So if I look at my x's, I have 3 on top, 5 on the bottom, which means I'm going to have 2 more on the bottom than on top. And then if I look at my y's, I have 2 on top, 1 on bottom. I have 1 more y on top than I do on bottom. So my final answer here is going to be y over x squared. Y over x squared. If I move on to something like this, this is where that simplify first comes into play. So I'm going to simplify everything first. So if I look at this top right here, I can simplify that by taking out a 2. Because 8 and 6 both have 2 in common. So I would be left with 4a minus 3. If I look at my bottom here, 5 and 20 both have 5 in common, so I can take a 5 out and I'm left with a plus 4. Now if I go to my second, 2 and 8 both have 2 in common, so I could pull out a 2. And I would be left with a plus 4 on top. And on the bottom, I can't pull out anything, so I leave that just as 4a minus 3 on the bottom. Now from here, what I'm going to do is just multiply straight across. So I'm going to multiply my coefficients, my outside numbers, and I'm going to get 4a minus 3, a plus 4 on the top, over 5, a plus 4, 4a minus 3 on the bottom. And if you look at this, then you ask yourself, well, what can I cancel? Well, there's a 4a minus 3 on top, 4a minus 3 on the bottom. There's an a plus 4 and an a plus 4. So all I'm left with is 4 over 5, which cannot be simplified anymore, so I keep it just like that. Let's look at number 4 here and see what we can do. So on the top of my first equation, I can't do anything. I can't do anything to the bottom, and I can't do anything to this one either. So I can't simplify anything before I do what I got to do. Since this is division, we keep change flips. So we're going to have x minus 1 over x plus 3 squared times, flip my fraction, x plus 3 squared over 1 minus x. From here, I'm going to go ahead and combine my stuff. So I'm going to end up with x minus 1, x plus 3 squared over, I'm sorry, this is a cube, sorry. So this one's cubed over x plus 3 squared on the bottom, 1 minus x. From here, I see what I can cross out. So I have 3x plus 3's on the top, 2x plus 3's on the bottom. So I'm left with x minus 1, x plus 3 over 1 minus x. And then if I look at this 1 minus x and this x minus 1, they are very close to being the same. But I need to manipulate this bottom a little bit to change it. So nothing is going to happen to my top. That's still going to be this x minus 1, x plus 3 on the top. But what I'm going to do to the bottom is I'm going to flip where those numbers are. So now I have this negative x plus 1. I don't really like that color. Let me do a darker gray. So all I did here was just flip where my x and my 1 were on that bottom. So when I do this, you can see that I'm getting closer to that x minus 1 on top, but I'm going to do one more thing on the bottom. And I'm going to factor out a negative 1. And when I do that, I end up with x minus 1 on the bottom, which makes me happy because then I can cross out my x minus 1's. And I'm left with x plus 3 over negative 1, which you could also just say is negative x plus 3. All right, moving right along, I do have 2 more practice problems to do, and then I'm going to let you guys loose on your own. So what we're going to do for this one is we're going to look at our top, see if we can simplify, look at our bottom, see if we can simplify, and then look at the other 2. So just starting with the top, I need to ask myself, are there any 2 numbers that I can multiply to get negative 15 but add to get negative 2? So I need to multiply to negative 15, add to negative 2. So what happens is I have x minus 5 and x plus 3. So negative 5 times 3 gives me negative 15. Negative 5 plus 3 gives me negative 2. And I'm going to do the same thing to the bottom here. So I'm going to ask myself, are there any two numbers that multiply to give me negative 5 and add to give me negative 4? Which again, it's x minus 5 and x plus 1. So negative 5 times 1 gives me my negative 5. Negative 5 plus 1 gives me my negative 4. So from here, I'm going to move on to my other equation. So I'm going to look at the top of this, and I'm going to ask myself, what are the two numbers that multiply to give me 7 but add to give me 8? And that is x plus 7, x plus 1. And then I'm going to do the same thing to the bottom. Two numbers that multiply to give me 12 and add to give me 7. And that is x plus 4 and x plus 3. From here, I'm going to combine. So I'm going to multiply, and what I'm going to do is just combine straight across. So I'm going to have x minus 5, x plus 3, x plus 7, and x plus 1 on the top. And on the bottom, I'm going to have x minus 5, x plus 1, x plus 4, and x plus 3. From here, I'm going to ask myself what I can cancel out. So there's an x minus 5 on the top and on the bottom. There's an x plus 3 on both the top and the bottom, and there's an x plus 1 on both the top and the bottom. So all that I'm left with is x plus 7 over x plus 4. So again, all I did was factor to simplify, combined, and then canceled out anything that was the same. So if we look at this next one, same procedures, except this time it's going to be division, but I'm still going to have to see what I can factor for the top and the bottom. So starting with the top, there is no number that I can multiply to get 1 and add to get 3. Also, my a value here is 2, so I need to do the AC method, and I need to multiply my 2 times 1. So 2 times 1 gives me 2, so I need two numbers that multiply to give me 2 and add to give me 3. So two numbers that are going to multiply to 2 but add to give me 3. And that's going to be 2 and 1. So what's going to happen here is I'm going to break all this apart. I'm going to have 2x squared plus 2x plus 1x plus 1. All over, and then I need to factor my bottom. So two numbers that multiply to give me negative 15, but add to give me 2. This one's going to be kind of similar to the last one. So this is going to be x plus 5 and x minus 3. And if you can't do them as fast as I can, that's okay. I've been doing this for a long time, so kind of got the hang of it by now. Now we're going to look at our next set. So we're going to factor the top and factor the bottom of this one. So on the top, we're going to end up with x plus 5 and x plus 1. And then on the bottom, ours is going to be a little bit longer because, again, we're going to have to multiply a and c. And we need two numbers that are going to multiply to give me 6, but are going to add to give me negative 7, which is going to be negative 6 and negative 1. So if I break that up, I'm going to have 2x squared minus 6x minus 1x plus 3 on the bottom there. From here, I'm going to group my tops and my bottom to factor once more. On the top, I look at what I can pull out, and I can pull out a 2 and an x. And if I do so, I'm going to be left with x plus 1. And then what can I pull out of the second parentheses? I can pull out a 1, and I would be left with x plus 1. So again, if you remember, we want our parentheses to match, which they do, and that makes me happy. So I'm going to just factor this one more time and just say that my two factors are 2x plus 1 and x plus 1 for my top. And on the bottom, I have x plus 5 and x minus 3. If I look at this one over here, my first set of parentheses, again, I can pull out a 2x and I would be left with x minus 3. And in the second set, I'm going to pull out a -1 and I'll be left with x minus 3. So my factors for the bottom on this side are going to be 2x minus 1 and x minus 3. From here, I need to keep change flip, so I'm going to keep my first fraction. Flip this, change this to multiplication and flip my last fraction. Next, I'm going to combine and simplify. So when I combine, I get this on the top, and I get this on the bottom. Last step is to simplify, see what I can cross out. So the only things that I can cross out is this x plus 1 and my x minus 3. So I'm going to end up with 2x plus 1, 2x minus 1 over x plus 5 squared. And the reason why I can say that it's x plus 5 squared is because I have two of them. So I just simply put them together and call it a square. And that is how you do that last problem. So the last problem was a lot of work. We had to factor the long way, and then we had to combine things, flip things, change things to kind of get where we wanted to go. There is a copy of these notes in the assignments tab for today. And your task is to do 1, 2, 3, 4, 5, 6, 7, and 8. I'd like to say that these aren't too bad. Most of them are multiplication. You only have 2 division ones that you have to do, so you only have to keep change flip twice. And if you have any questions, please let me know. But that's about it for the video. You treat them just like you would for fractions, except they're